Okay, so on number 26, we're going to run into a similar issue as the one previous, because if we try to plug in 2, we're going to have 2 minus 2, which is 0 in the denominator. So we have to use algebra to manipulate this function a little bit so that we can plug 2 in. So in this case, I would factor the top and see if we can get a factor to cancel. So we get x times x gives you x squared. We'll have 5 and 2, and then both of those need to be negative to multiply to give us positive 10 and add to give us negative 7. And then x minus 2 cancels. So using algebra to simplify this, it boils down to the limit as x approaches 2 of x minus 5, and then we can plug in 2. So we get negative 3. On number 30, we have a similar issue. We'll get 0 if we try to directly plug in 0. So we're going to have to simplify some things. We don't have a good way. We don't have a good way of factoring it like we did the one above, but we do have a greatest common factor. So let's start with that and see what we get. On top, we have a greatest common factor of y squared. If we factor out a y squared, then we get 5y plus 8. And then in the denominator, factor out a y squared, we get 3y squared minus 16. And then we can cancel out our y squareds. At that point, I think that we've got enough that we can go ahead and plug in 0. So we'll have 5 times 0 plus 8 over 3 times 0 squared minus 16. So we've got, actually I'm going to move this down here. We've got 8 over negative 16, which is negative 1/2. And I know I'm moving kind of quick on these, but I figure you can pause and play back the videos all you want. So on number 36, if we plug in 4 directly, we're going to have 2 minus 2 in the denominator, and that's another 0, so that's a problem. So let's try factoring. Up in the top, we have a greatest common factor of x, which leaves us with 4 minus x over 2 minus square root of x. This is the kind of factoring that you don't see very often in algebra, but you do actually end up with sometimes in calculus. 4 minus x, we don't usually think of that as a difference of squares, but it actually is, because 4 is 2 times 2, and x is square root of x times square root of x. And then difference of squares factors with plus and minus. So I wanted to do that one just because the factoring does look a little bit different. But then that allows you to get rid of that denominator that was problematic. And then we can plug in 4. So we have 4 times 2 plus square root of 4. So that'll be 4 times 2 plus 2. So 4 times 4, which is 16. On 54, they're giving you some practice with the definition of the limit laws. So they've given you that as x approaches 4 for the function f, that always equals 0, and for g it always equals negative 3. So down here, they're just wanting you on part A to practice your limit laws, which the limit laws say that if you have the limit of a sum, that you can break that up to the sum of the limits, and then this value here we were given. That's this one. So we know that this value is negative 3, and then the limit of a constant is always the constant, so we get 0. Down here, same thing. If we have the limit as x approaches 4 of x times f of x, we can think of that as the limit as x approaches 4 of x times the limit as x approaches 4 for f of x. As x approaches 4, we plug in 4, we get 4, and then we know what the limit for the function f is. That was 0. So that answer is 0. For the g of x squared, go back to your g of x, it was negative 3.